Here we go with some more anti-differentiation. We are going to look at some strategies for finding the antiderivative when we can't do a U substitution. We don't just know what the antiderivative is, and integration by parts doesn't work. So in this first example, integral x square root 2x plus 1 dx, this is a radical linear expression. Right in there we have a linear expression underneath a radical. What we're going to do in a situation like this is we're going to take the entire radical and we're going to make that our substitution. We're going to rewrite the entire integral in terms of that new variable. So I'm going to use t just for fun. Let t equal square root 2x plus 1. We can solve this little equation for x. We get that x is equal to t squared minus 1 over 2. And using that, we know that dx is equal to t dt. These two pieces, we will need to replace the x and the dx. So let's do that. Let's see what this becomes. So integral of x, t squared minus 1 over 2, times the radical, which I defined to be t, times dx, which is t dt. And if we do some simplifying here, we get 1/2 times the integral t to the 4th minus t squared dt. And that, ladies and gentlemen, that is something that we know how to take the antiderivative of. It's fairly easy, in fact. It's just the power rule. So 1/2 times 1/5 t to the 5th minus 1/3 t cubed plus c. So this becomes 1/10 t to the 5th minus 1/6 t cubed plus c. And we'd be tempted to stop here, but we better not, since t was an invention of our own. We need to put back our x's. So this becomes 1/10. And instead of square root 2x plus 1, let's think of it as 2x plus 1 to the 1/2. So it's 1/10 times 2x plus 1 to the 5/2 minus 1/6 times 2x plus 1 to the 3/2 plus c. And ladies and gentlemen, it would be just fine if we left it right here on an exam most of the time. However, it's not how you're going to be presented with the answer if you were to check it, say, in the back of a book. If you're working on problems and you have the answer available to you, it's going to be simplified further than this. So let's see how that works. We're adding two fractions together. We're going to need a common denominator, which is 30. And both of these terms have 2x plus 1 to the 3/2 in them. So times 3 times 3 times 5 times 5. And I'm going to take the 2x plus 1 to the 3/2 out. And what I'm left with is 3 times 2x plus 1 times 5. And this is all over 30. And of course, we're adding our good friend c. And then doing a little bit more cleaning, a little more simplifying. We have 6x minus 2. And we can factor a 2 out of the brackets here and reduce with the over 13. So our final glamorized, beautiful answer, our antiderivative, 2x plus 1 to the 3/2 times 3x minus 1 all over 15 plus c. Again, back here in blue, completely okay to stay at. However, if you're checking your work against the back of a textbook or someplace else, odds are they're going to go through this algebraic simplification. Next example, bigger and beefier, and I'm going to give you a slightly different way to do this. It's a similar situation. A U substitution is not going to work, nor is integration by parts. And we have a linear expression under a radical. Instead of letting the whole radical be our new variable, we could do like we did with u substitutions and let what's inside be our new variable. So I'm going to say let u equal 2 minus 3x. But instead of finding du, let's take this and solve for x. We're going to get 1/3 times 2 minus u. And dx is then negative 1/3 du. And we can now take those bits and pieces and substitute them into our original integral. We have 3 times x squared, so 3 times 2 minus u over 3 squared times u to the 1/3, and dx was negative 1/3 du. And we can expand and simplify, and what we end up with, if we do this carefully and correctly, we should get negative 1/9 times the integral of 4u to the 1/3 minus 4u to the 4/3 plus u to the 7/3 du. And again, this is simply power rule integration. This is something that we can and very easily deal with. So let's do it. We've got negative 1/9 times, now here come the antiderivatives, 4 times 3/4 u to the 4/3 minus 4 times 3/7 u to the 7/3 plus 3/10 u to the 10/3 plus c. And we can clean this up a little bit here. We have negative 1/3 u to the 4/3 plus 4 over 21 u to the 7/3 minus 1/30 u to the 10/3 plus c. And we really could at this point just make our substitution for what u is, and we could call it good. And this is a perfectly valid answer, but again, if we're checking against something else, someplace else, back of a book, answer key, what have you, it's probably going to be simplified. It's probably going to have some algebraic work done. So let's go through that process. So before I make my substitution, I look at these 3 terms that have u's, and I notice that all of these terms have u to the 4/3. So I'm going to take u to the 4/3 and factor that out. And I'm going to take a negative along with it. And what I end up with at this point is 3 fractions being added together that have nice exponents. And these fractions, I need a common denominator. And the common denominator here is 210. So my numerator, once I have common denominators and I've worked on this, what I should end up with is 70 minus 40u plus 7u squared plus c. And I am glossing over some of the nitty-gritty details and how I'm going from here to here, but it's basic fraction work, ladies and gentlemen. I think we should be able to work on this a little bit and get there. If you can't, make sure you ask somebody. It's not going to magically fix itself unless you do a little bit of work with it. And now, I'm going to substitute for u. So I've got opposite of 2 minus 3x to the 4/3 times 70 minus 40 times 2 minus 3x plus 7 times 2 minus 3x squared. And this is all over 210. And the really nice thing about this, ladies and gents, is that stuff in the brackets that can be simplified. That can be expanded and like terms can be found, and then perhaps this fraction can be reduced. And that's actually what happens when we finish expanding this. We get opposite 2 minus 3x to the 4/3 times 18 plus 36x plus 63x squared. And this is all over 210. And that quadratic in the parentheses, that has a common factor of 9 that I could take out. And 9 over 210 reduces to 3 over 70. The nice clean version simplifies to negative 3 times 2 minus 3x to the 4/3 times 7x squared plus 4x plus 2 all over 70 plus c. And that, ladies and gentlemen, is where we shall stop with this first video. In the next one, we're going to look at what we do with some trig functions and some strategies for substituting there.